On today's Visual Studio Toolbox, we're going to see some neat tools we can use to improve our code coverage. Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today, Davide Bellone. Hello, how are you?
Hi there. I'm fine, thanks. You?
I'm excellent, and you're going to show us a lot about code coverage. We're going to dive into a little bit about how it works, and I think if we understand it better, then we can make better use of it when we're writing applications.
Yeah, exactly.
All right, so do a quick introduction of yourself for folks who aren't familiar with you.
Yeah, I'm Davide Bellone. I'm a backend developer from Turin in northern Italy. I've been working with .NET since 2014, so it's 10 years now.
Excellent.
So, yeah, cool. I'm a Microsoft MVP for developer technologies, and I also share content on my personal blog, codeforit.dev, and also on LinkedIn and Twitter at Bellone Davide. All right, and I'm also involved in public speaking. So, yeah, there's a lot of stuff going on.
That's awesome. Okay, what do I need to know about code coverage?
Yeah, today I want to show you how to create and run code coverage reports in Visual Studio 2022. And we are going to learn why the code coverage metric is important, but should not be the final goal for a project in general, because spoiler alert, you can cheat on the report and have a greater percentage than that does not represent the quality of your test. So I'm going to show you how to run the report, which are some pitfalls, and how to have a higher and why you should not consider 100% of code coverage the final goal for your code quality gates, for example.
Okay.
To do so, I created a simple API application, which kind of mimics the classic weather forecast API. This time, it's all about the universal weather forecast controller. So it's not just the weather for a specific location ID, but also for our whole planet. So we have two endpoints. One is, in fact, the forecast for a given location by its ID.
Okay.
And the other one is just the minimum temperature for the whole planet.
Okay.
As you can see, it's nothing fancy. It's a classical three-layer structure. So we have the controller, we have the service, and we have the repository. Today, we're going to focus on the test on the service layer. So yeah, it's this middle class. We have two methods. One is the forecast by location, which, as you can see, the first step, it checks that your location ID is greater than 0. Otherwise, it throws an exception. Then it calls a method on the repository to get the details of a location, again, given its ID. If the location exists, it just returns the forecast. Otherwise, it throws an exception. The other method is just a loop through all the location in a planet and the calculation of the minimum temperature. As you can see, nothing fancy. Just for completeness, the repository is in memory, some in-memory dummy data.
Yep. Okay.
Again, it's a pretty simple API project. Okay, but as we said, code coverage is an important metric because we can say that the higher your code is covered by test, the more is covered by test, the less is the probability to have bugs in your code. So we should tend to have a high percentage of the code covered by your test. So let's see how I created this test. It's a pretty simple unit test project with an unit and MOQ.
Okay.
Or mock. Here we create a mock of the repository. instantiate the service. So yeah, we are focusing again on the middle layer, so the service. And we have just two tests. One for the case when the location exists. So we are focusing on the method that returns the forecast given its location. So the first test is a check on the behavior when the location exists. So it should return the forecast. And the second method is covers the case when the location does not exist. So we are checking that the method throws an exception of type, in this case, location not found exception.
Mm-hmm.
Okay, it's just these two methods. Of course, it's not enough for a real project. So just 2-unit tests testing one single method in the whole project, of course, it's not enough. So how can we validate if we covered enough methods and classes in our projects? So of course, by running our code coverage reports. To do so, we have to install a NuGet package in all our unit test projects. So if you can see here, I've installed the coverlet.collector, which is a NuGet package. It's basically a library that analyzes your code and the code that is executed when running your unit test, and creates a file, a metadata file, that will be used later from another tool.
Okay.
So we have coverlet.collector installed in all our unit test projects.
So does Visual Studio have any code coverage tools in it, or do you always have to download this NuGet package?
I generally tend to install it because I find it pretty handy.
Okay.
Actually, with MS Builder, there is a sort of collector, but it has some known bugs. So one of the suggested approaches is to use Coverlet instead.
Okay.
So yeah, I would stick with Coverlet right now. Then the other part for running and having our reports in Visual Studio is to install a tool called ReportGenerator. To install it, you have to open a PowerShell in admin mode around the commands you can see here. So we are going to install globally ReportGenerator tool and then install it in our very project.
And that's part of .NET, or that comes down with Coverlet?
It's a totally different tool. So it's
Okay.
we are going to use two different tools.
Got it.
So Coverlet to create the metadata file, and the other one, ReportGenerator, to create to visualize the result of the data of
Okay.
of the code coverage. So again, we have to run all these commands in PowerShell, and we are almost good to go, because the last part missing is to install in Visual Studio an extension. So we have to go to extension, to the extension tab, of course, and search for Run Coverlet. Okay. We have a Run Coverlet report for Visual Studio 2022. There is a similar extension for the previous versions of Visual Studio. So you just have to install it, restart Visual Studio, and you'll almost good to go. After installing it, you will see that under the Tools tab, you can see two different labels. Yes, exactly. One is for running the code coverage report, and the other one is for the toggle of the highlighting of the code. So it just tells you that if the code is highlighted with red color, it's just not covered by any test. Otherwise, it's all green. We have just one final thing to check. So again, here under Tools, we have to go to Options. Here we have to search for Coverlet. So it's just the configuration for the extension we just installed. And search for this value integration type. We should select collector and not MS build because of the issue I told before.
Okay.
So we should prefer using the collector rather than MS build. And we are good to go. We have everything in place. We just have to run our unit test first to, let's say, initialize the different metadata and the library, so coverlet. So you will have to do this just for the very first time.
Mm-hmm.
Then we can actually run the tool. So again, we have to go to under tools, run code coverage, and see the final result. As you can expect, we have just tested one single method, so the percentage will be pretty low.
Yeah.
Let's see, it's running some tools.
There we go. Oh,
okay.
Interesting.
Here we are. So we have a 16% of line coverage in the whole project, of course, and of branch coverage. So it's pretty low as this values, as you can see. This tool is fine because it also creates a list or better a table for every class in your project, telling you how many lines are covered by tests, how many branches, the percentage, and so on. And you can then click on any of those links. I know there are some bugs on the layout, but it's nothing fancy.
Mm-hmm.
But still, you can see which are the methods that are not covered by any test in this specific class. So it's all red, and you can also have a kind of report of the information for this specific file or this specific class. Yeah. So it's the line coverage is 40%, the branch coverage is 32%. So focusing on this specific file.
So as a DevOps thing, using either Azure DevOps, Azure Pipelines, or GitHub Actions, you can automatically have your tests run after you check in code. Can you also set up this code coverage to run after the tests every time you check in code?
Yeah, you can. There are some extensions. I tried it personally on Azure DevOps. There is an extension to install that just blocks the pull request if you have not reached the specific value of code coverage, and also if the percentage is decreased compared to the previous iteration. So
but you could. I mean, I could see you. The beautiful thing about having your tests run automatically is you don't have to do it, and you can never forget to do it.
Exactly.
I think you'd want to get in the same point with this tool as well. If you're going to run all the tests, you might as well check the coverage while you're at it, especially since it's all automated and you don't have to sit there and watch it, right?
Mm-hmm. Yep, exactly. Yeah, cool. It's generates a report that is pretty similar to the one we are seeing right now in Visual Studio.
Excellent.
Okay. So we noticed, yes, in fact, that 16% is pretty low. So we should, for sure, create some more tests. But as I said before, having 100% of code coverage does not guarantee that your code is bug-free, because simply you can create useless tests, or even worse, you can cheat on the result. And let's see why you should aim at a good, at higher percentage, but you should always focus on having valuable tests rather than just targeting the higher number.
Sure.
So, as you recall, the word of service. Okay, let's focus on the forecast by location. Even though this method is 100% covered by tests, we forgot. Well, I can now toggle the highlighting because it's pretty hard to read it. Okay, even better. Okay. Yeah. As you know, we just wrote 2 unit tests on it, even though here we have the 100% code coverage. But we forgot to test 2 specific cases. The very first one is that, okay, what happens when location ID is less than 0? We should have created a test to validate what happens and to make sure that our argument out of range exception has been thrown. But okay, we didn't have that kind of test. The other case that we forgot to cover is when the getLocationById throws an exception. Here in this case, code coverage tools just run static analysis on the code. They cannot know what happens behind the scene. So they don't know that getLocationById could throw an exception. So this is one of the unit tests that we forgot to write, even though, as I said, here we have 100% of code coverage.
Right.
So yeah, it's an important metric, but we should not only rely on it to say that, okay, our code is bug-free. This is one of the reasons. There is another reason. So here we have a unit test class for the repository. And it's pretty useless, as you can see. Here we have, okay, it's the classic test class. We instantiate the real repository, call the getLocationById, call the getLocationByPlanet, do nothing with the result, and our test just asserts that that 1 is equal to 1. So our unit test is totally pointless.
Yeah.
We have called those methods in the repository, but the test does not check anything at all. Now that we have uncommented it, we can run again our test, run our code coverage report, and see that the percentage is slightly better than before. So if I remember well, we had 16% of line coverage and 25% of branch coverage. Let's see now the result.
Ooh, look at that.
Yeah, with just one single useless method, here we have the 53% of code coverage. So again, the most important part is that your test should have a reason to exist, and they should actually test your code and not just call some random methods. Otherwise, yes, you can certainly reach a high percentage.
Who would do that, though?
I saw it in some projects. I cannot tell you more.
We won't name names. But it has happened.
Here we have the list. Okay, there's one even worse reason to, even worse way to cheat on it. Sorry, wrong keyword layout. Exclude from code coverage. This is a fancy attribute that you can apply on methods and classes that just tells you that the code coverage report should exclude this specific class or method from the final calculation. So we can place it on our service, on let's do it on the controller, you know what, even on the repository, and maybe on the directly on the program class, because why not? So yeah, we have not added any file. We have just excluded everything. Let's run again our tool.
Well, that should dramatically increase the coverage because you reduce the denominator by quite a bit.
Yes, indeed.
All right.
And in fact, here we have the 81% of code coverage without having written any single test.
Right. Because you've dramatically reduced the total lines.
Exactly.
Huh.
We just excluded almost everything.
Mm-hmm.
We just have those 3 classes, which, by the way, are just some Poco classes, so we shouldn't have even tested them at all.
Right.
So yeah, this is these are my top reason why you should aim at a high percentage, but not sacrificing the quality of your test. So for sure, a high. Okay, let's say that a low code coverage percentage tells you that you forgot to test your code and there is high probability to have some bugs.
Mm-hmm.
But a high percentage does not guarantee you to have no bugs at all, because as we said, tests can be brittle or they cannot cover some cases, or you can just exclude everything just for the sake of having a high percentage. So yeah, we should always run our code coverage reports, in my opinion. But of course, it's not just the number; it's all the work behind it that matters.
Very cool.
Yeah, that's pretty it.
All right. That's awesome. Any other tips and tricks for people thinking about this? Do you find that people in general run the code coverage? Is it ignored by most people? What do you think?
I suggest to maybe start focusing a little more on integration tests rather than just unit tests, because it shows you some real usage of your code and not maybe using stubs or mocks as I showcased here. So yeah, for sure, running integration tests allows you to reach a higher code coverage percentage, but also test the actual execution of your code. So in my opinion, the so-called testing diamond should be preferred over the testing pyramid.
Okay.
And it also reflects the code coverage and which parts of your code still have to be tested or are covered partially by your test. So yeah.
Excellent. All right. Very, very cool stuff. And so we looked at a NuGet package. We looked at an extension. Tell me a little bit more about the .NET report generator. .NET knows where to go get that. And did I have to do anything? Do I have to do anything before I can type .NET report generator from the command line?
You said this one?
Yeah, .NET install. So .NET report generator global tool. That just shows up automatically. I'm admitting how rarely I use the command line.
Yeah, me too. I know that I have to run those commands because I always do that.
And to get a NuGet package, I know I got to go to the NuGet package manager. And to get an extension, I know that I go to the extension manager or the marketplace. But if I just go to the command line and type .NET install .NET report generator global tool, it will automatically know where to go get it. Is that true?
Yeah, I suppose so. Yeah.
Okay, cool. All right, awesome. Well, thanks so much for coming on the show and showing us this stuff. Very, very interesting. And
it's been a pleasure.
A lot of fun. And hope you guys enjoyed that. And we will see you next time on Visual Studio Toolbox.